Okay, guys, grab out your notes. We're going to finish up the notes for today. When we finish the notes for today, it's your choice. You can work on the stuff that you want to get handed in before the 14th, or you can do the chemistry screener, which will let you know in chapters 1 through 10 what you're missing, what you don't understand. I do want all of you to do that so I can look overall and see where we're weak, so that when I review chapters 1 through 4, I know what to really focus in on. Okay? So we will have next time to also do that. And we also have a chemistry screener that is from the district that they want you to do. So this is the plan. Today we finish up. You can start this chemistry screener. There's the code. You just go to alex.com, click the yellow button, enter the code, and then it will take about 45 to 60 minutes to complete. Then on the 10th, we'll do chapters 1 through 4. On the 14th, 5 through 8. On the 16th, 9 through 13. And then on the 20th, I will go over the last questions that you have with the review that I hand out for you to do on probably the 14th. Then we have our year final, which is 20% of your grade. So you really want to study hard for this test and make sure you ace it. And then the 24th, we'll move classrooms, clean lab, maybe do a glass lab. And then the 28th, we'll plan on making ice cream, freezing point depression lab outside. Next door. Okay? Just one class over because they've got the biotech class. I'll be taking over biotech and medical forensics.
And you're still doing chem?
Yep, I'm still doing CE Chem.
Man, that's crazy.
Yep, it is.
Are they giving you a pay raise?
Yeah, right. Okay, so what page did we, every class ended up at a different spot, so where did we end up?
Focus on health and medicine, but where is your rain hard?
Right here? All right. Okay, so I'll get you in just a minute and let you know what's going on, so just chill for a minute. All right. So saturated fats are just that. They've got as much hydrogen as they possibly can have in them. Butter is a saturated fatty acid. Saturated fatty acids are considered unhealthy. Scientists have tried to get alternate versions of butter like margarine with similar tastes and properties, but with some C-double-C bonds. That is unsaturated fatty acid chains. The Mediterranean diet actually, instead of using butter on their bread, they sop their bread in olive oil with flavorings in it. That is actually healthier than putting butter on it. We okay?
It's crazy. This is the first time that I've done a Living Smarts before the notes, and I understand.
Duh! Okay, sorry.
It's kind of nice.
Yeah. Acid chains. Okay, focus on medicine. Most naturally occurring unsaturated fatty acid components are liquid at room temperature. That's why the Mediterranean diet with olive oil is better for you. Things that are saturated are usually solid at room temperature. When we partially hydrogenate, so if we take an oil and we partially hydrogenate it, then we get a soft solid. This process allows for only a few C-double-C bonds to remain on the chain, making the solid fatty acid that is not naturally occurring. For those that are watching on the video, that bottom line, not naturally occurring, because you can't see it all. And some would argue butter is naturally occurring, therefore it's better for us. There's arguments both ways. Okay, going forward. Okay? All right, so if we look at the difference between butter and margarine, you can see, do we have cis or trans?
Cis.
It is cis because the two hydrogens are on the same side. So we have two cis bonds in vegetable oil, but if we partially hydrogenate it, only one cis, it becomes very spreadable. So it's not like butter that's hard, but it has a spreadable ability. So they call it semi-solid. Okay. You good to go? All right, so up at the top you can see a saturated chain. The saturated chain, then we go to an unsaturated. That's a cis. Then we trans down at the bottom. Some partially hydrogenated leave trans bonds, not cis bonds, because we can't necessarily say that's the kind that we want left. So trans fats are very similar in shape to saturated fats because our body can't get in and split them up. So they're considered just as unhealthy. And nutritionalists agree that healthy diets consist of very few saturated or trans fats. So Jacob here eating our trans fat in our Oreo. Though it may be yummy, is not good for us.
The bottom is very small.
Very few. Very few on the bottom. Okay, going forward. Trans fats and saturated fats have a similar 3D shape if you look at them. The trans and the saturated look very much similar as far as to the body. So polymers are our next thing that we need to talk about. Polymers is where we get plastics and versions of plastics. Ethylene monomers. A monomer is just the original unit that has a double bond in it. When we make a polymer, we break the double bond and we attach a long strain. So up here is, excuse me, I've got the hiccups now. Up here is shown 3 monomers, units bounded together. Synthetic polymers help us to make lots of different things, especially now new athletic clothing and stuff like that is synthetic polymers. A monomer has a double bond. It's broken into single bonds when we form a monomer or a polymer. Now, instead of having to write the monomers over and over again that have formed a polymer, we end up making a shortcut or a shorthand structure where we just show one monomer and how it's going to attach to the others, and we always put an N there because we don't know how long the chain really is. It just depends on how long it wants to go on and on and on and on. So that's a shorthand version. Here are some that we've used. PVC, polyisobutylene, polyacrylonitrile, and then polystyrene. Polystyrene and PVC probably you're most familiar with, hearing people say PVC or polystyrene or foams. Probably the others not so much. They just call it, playground rubber or textiles. Okay, so aromatic. Aromatic is a benzene ring. Every other bond is a double bond. Now, with this, it actually forms a very strong structure, benzene ring does, because that double bond is going in and out, and it's sort of, what you end up with is 6 carbons in a hexagon, and above it you end up with like a donut shape of electrons, and then below it you donut shape of electrons. And they share evenly, those electrons. And because they share evenly those electrons, it's a very strong structure. The shape that the atoms go in is trigonal planar. It's 120. The whole thing, benzene, remember we made it? It's planar. Okay? Yep, that's the circle thing you made last time. So, because benzene can sort of flip in space, you never know where the double bond is. So that's why we put that circle in the center saying it moves. Each representation has the same arrangement of atoms but different locations of electrons. These are resonant structures, and neither is really the true structure of benzene. The actual structure is a hybrid, and like I said, it's the 6 carbons with basically a donut shape of electrons on top that is shared between all of them and a donut shape underneath that's shared with all of them. We good to go? Okay, in this hybrid, all 3 electron pairs in the double bonds are delocalized in the 6-member ring. So we draw a circle. Excuse me. And that circle is basically to represent, here's my hexagon of carbons, and above that is a ring of electrons, and below that is a ring of electrons. So they're delocalized. They're not assigned to any specific one, sort of like when we do our metals and how they conduct electricity. Okay, that gives it stability. It's very, very stable. A benzene ring is very stable compared to other unsaturated hydrocarbons. Aromatics, hydrocarbons do not undergo addition reactions. So if I look at it, remember how it would break up the double bond when I had a double bond, when I had bromine, and it would go on either side of the double bond. We don't do that with aromatics. Instead, we can do substitution reactions, but not addition reactions. Okay, when we monosubstitute, meaning one thing's attached to a benzene ring, we just name that and then name benzene. So you've got ethylbenzene, butylbenzene, and chlorobenzene. Remember on the halogens we do fluoro, chloro, bromo, iodo. So you'd name it first. Since there's only one, we don't have to use numbers. We just name it and name the benzene ring. Okay, go forward. These are ones that you will want to know. Star it, circle it, square it, whatever you want to do, color it. Make sure you know these. Okay? These are some monosubstituted benzene rings that have common names, and you do need to know them. If it has a methyl group coming off of it, it's known as toluene. If it has an OH group coming off of it, it's known as phenol. If it has a NH2 group coming off of it, it's known as aniline. Okay, going forward. If I have 2 things on a benzene ring, we would normally go alphabetically, right? We normally say where they're at, 1, 2, whatever. But this position right here, when they're right next to each other, is known as ortho, and we use O. This is known as meta, and we use M, and this is known as para, and we use P. And they are lowercase. They're treated as a number. So the middle option there, the O-diethylbenzene, the M-diethylbenzene, and the P-diethylbenzene are the preferred naming. So the middle there is the preferred naming. The way that I remember it, if there's 2 things, orthos, like going to the orthodontist, you're trying to get your teeth right next to each other. So they are right next to each other off of a benzene ring. Meta, I just met you, give me a space. Don't get it up in my space. Okay, give me a space. Para, we're exactly opposite. Okay, so try and remember, it doesn't have to be drawn like this. It could be drawn on its side a little bit, and we'll do some practice with that later. But that's just the position. Ortho, right next to each other. Meta, one space in between. Para, directly opposite. You seem a little bit more fidgety than normal. All right, we going forward? Okay, so if we have 2 coming off, we do it alphabetically, but we try and use the O, M, and P if there's just 2 coming off. So on the first one here, we would do O-bromochlorobenzene. So you still do it alphabetically, but you're just saying what position they're in. M-ethylfluorobenzene.
So how do you know which one to start with? Oh, it just...
Alphabetically. Good to go? All right, so when we have a benzene ring and it's substituted and it's one of those 3, remember we talked about, we need to identify that part. So on this first one, what's shaded here is a toluene. What's not part of that toluene is the bromine. So then I look at where the methyl group is compared to the bromine, and they're opposite, so I put p-bromotoluene. On the far one, the shaded area includes a phenol. And so again, with your color pencils, it's a lot easier to shade the whole thing that I know goes together and has a name here, and then what else is left out. And it's the chlorine. And the chlorine is right next to the OH, so it's in the ortho position, so I would put O-chlorophenol.
Can you explain the two in the phenol? Is that just the
Yeah, that's what's in the shaded area. Those were the names I told you earlier to star, that you'll need them. Okay? They're derivatives of benzene. Okay, so polysubstituted benzenes. We want the lowest numbers. We want to alphabetize them. When the substituents are part of a common root, name the molecule as a derivative of that monosubstituted benzene, like with phenol or toluene or aniline. Put the common root substitute as C1, but omit the 1. So, like the toluene, I would start right at that methane group. If it was the phenol, I'd start right at the OH group, counting. Okay? We good to go forward? All right, so this is an example. On this one, this is a polysubstituent. It doesn't have a monosubstituted benzene ring that has a specific name. So I want to look at each of this. This one starts with a C, this one starts with an E, and this one starts with a P. But if I start with the one with the C, then I'm going to have larger numbers than if I start with the one with the E. So remember, numbers come first, then alphabet on this. So numbers here, I start at the E with a 1, then go to the 2 for the propyl, and then 4 for the chlorine. So when naming it, I still put it in alphabetical order, but I numbered it so I get the lowest numbers. Does that make sense? Okay. So this would have been 3, and this is 5, and this is 6. Everybody okay with that? Any questions on that? Name is down here at the bottom. 4-chloral, 1-ethyl, 2-propylbenzene. Okay. So here we have a polysubstituted one. We are going to start with the nitrogen on the aniline, and then we'll go the shortest direction to get the lowest numbers, and that would be to the left or counterclockwise. So a chlorine at 2 and a chlorine at 5. We still use our, for those that can't see the bottom here, it's 2,5-dichloro aniline. I think it was out of order is what they were telling me last period. So look and see if you got it there. It's just out of order. It's off to the side, they said. So go back where you were. It's off to the side. Okay, we all right? Found it? Off to this. It's just the picture. Yeah, the word's not there. So just remember, you're going to start numbering at 1 wherever the thing coming off that you named as a group is. Okay? There are also 3 others that you need to be aware of. Again, the bottom one got cut off for those that are watching online, so I'll write it up here. The naphthalene is what is found in mothballs. Very stable. Anthracene and phenanthrene are used in a lot of drug manufacturing. Okay, so going forward here. Here are some common drugs. Loratadine is down at the bottom, which is a trade name of Claritin. You can see it has 4 rings. Only 2 benzene, well, 1 benzene ring, 1 nitrile ring. Zoloft has 2 benzene rings, and acetaminophen has 1. Okay, so focus on health and medicine. Here's some more things. A lot of people are saying we don't want PAPA in our sunscreen. This is what PAPA is. It's para-amino benzoic acid. A common environmental pollutant that is a potential carcinogen that a lot of people start barbecuing now and are making this is benzoaprene, which is down there with 5 benzene rings. Actually, it doesn't have 5, it only has 3. Because these, 3, 1, 2, 3, 4. This one is not a benzene ring. Okay? Reactions with aromatic compounds. So now we're into the reactions. So it does not do an addition reaction. Will not do an addition reaction. It only does substitution. So in a substitution reaction, it will take and substitute a hydrogen, and they just drew the hydrogen here so that you could see that that's the hydrogen that's replacing. These two just switch places. So it's a substitution, it is not an addition. So you got to make sure you're careful with that. And you get an acid off of it. So some kind of acid is produced. Same thing with chlorination here. It is a substitution, not an addition reaction. So only one chlorine goes on to these two trade places. So you get an acid in the end. Okay, so a substitution, not an addition. And the pesticide DDT is formed by chlorination reaction. You can see it down there at the bottom. We've got 2 benzenes that have a chlorine on them with a ethyl group in the center with 3 chlorines off it. And it is non-biodegradable. Once it's out there, it's out there. It doesn't ever go away. Okay, nitration of drugs. This is important that we realize that we need both sulfuric acid and nitric acid to make a nitrobenzene, and you need to be familiar that this is nitrobenzene. This is another one you will need to know how to name. Know the special name of it, nitrobenzene. On this one you do make water, so it is a dehydration reaction. Okay, it is substituting. It's a substitution, but it's also what they call a dehydration reaction. Okay? Any questions with nitration? Then we get sulfa drugs. Here are some sulfa drugs that you might be not familiar with, but you might have used. Sulfoamide, also known as Septra. Can't remember the brand name of it. Okay, and then p-amino benzoic acid are the 2 sulfa drugs in the sulfa class. To make sulfonation, and detergents, we use sulfonation, which we need both of these, SO3 and H2SO4, to make a benzyl sulfonic acid, which is this. And you do need to know how to write them. Detergents are made with sulfur, and they're salts of the sulfonation. So they've taken a sulfonic acid and replaced the H with a sodium, usually. It's the cheapest. Okay, going forward, time for examples. So I'm going to put some up here. We're going to do them together to start with, and then I'm going to have you guys, as I feel like you're getting it, I'm going to actually have you come up and name them. Okay, so let me bring up the other program, which does a lot better with me drawing, which is this one. Okay, here we go. All of our things. We'll do 4 at a time. We're in trouble. I think I'm actually going to start by having you come up and do this. I know. Make you stress out. Caleb is not here. Jacob, number 1. Justin, number 2. Tiani, number 3. Tyson, number 4. Jaden's not here. So as soon as you figure out what yours is named, go ahead and put the answer up. The rest of you keep trying. Okay, while they're doing one of you up there, come on. Come on, come on, come on. I need the rest of you. Justin, Tiani, Tyson.
I don't.
Which one do you see? Which?
I'm on 3.
The 3. Okay, so you have a toluene. This is in what position from the toluene? There's 1 point in between, so I just met you. I want my space. So M.
Yeah, meta.
And then 2 carbon is
Ethane.
ethyl.
Ethyl. Wait, I'm lost again.
So M, ethyl. What was that whole thing called? Starts with T.
Ethyl. I forgot the word.
Tol. Toluene.
Okay.
Should we name it like the aniline, or should we?
Yes. Amino is NO3. We don't have an, or NO2. We don't have an NO2
Well,
attached.
it just says aniline, and then in parentheses it says aminobenzene.
Yeah, we don't want to use aminobenzene. We want to use aniline.
Is it not the same?
It is, but we want to use the correct naming.
So that aniline, whatever.
Yep.
So is it propyl?
I don't know which one you're doing.
But like, say if it was just like how you name it,
Yeah, but you got to give me something in front of that to tell me where that's coming off. Whoops, sorry.
or like the P,
Toluene.
How do you spell
Toulene.
like the P.
Is that it?
Mm-hmm.
Okay.
Oh, no H though. T-O. T-U.
Oh, yeah.
T-O-U.
T-O-U.
T-U.
T-O-L-U-E-N.
Now you got me all mixed up. I can't.
It's T-O-L-U-E-N.
T-O-L-U-E-N.
Like that. O is next to each other.
Use your fist. Or pick up the eraser.
Right here. Next to each other is O, and it's one space, and P is straight across.
Okay, we got them?
I'm not done. I put that in just to say where it's. That's right.
Okay, let's look through these. See how we did. On the top one, it is a 1, 2, 3, 4, 5, which is pentyl, and it's a benzene. So pentylbenzene, done. Number 2, we have an ethyl group and an ethyl group, and they're right next to each other, so think orthodontics, close together. O-diethylbenzene, done. Next one, we have a methyl group and an ethyl group coming off, but this right here is known as toluene. So we have M, because there's one space in between, ethyl, toluene. Awesome.
I thought toluene was CH3.
That's what one line is. Okay, on this next one we have a 1, 2, 3, which is a propyl. It's directly opposite the NH2, so it's P-propyl. This group right here is known as aniline, and you've got it. Okay, how do we feel? Good? Okay, let's go on. Here's another 4. That's the way they do it because it's dissociated. It's not specifically there in any specific place. Okay, here we go. I did 2 twice? Oh, that. Okay, make that a 3. Okay. Carly, let's do 1. Aspen, 2. Caleb, 3. And Kayla, 4. When are you due? Tomorrow.
That's supposed to be a 8-month or 9-month. I don't know. I'm not excited.
It's hot. It's miserable. But it'll give you empathy for when you get married and you have your wife that is in the same position and she can't take it off. Okay, as soon as you get it done, guys, let's get up here and put in the answer. The sympathy just makes me laugh. By the way, as it's getting hotter, if you come in and you're hot, the fans, you're welcome to turn on at any time.
Okay, wait. On this one, isn't it an aniline?
It is.
But how would you do that part?
So that's a what?
Chlorine.
So you put in front chloro. What position's it in?
2.
What's another way to do that? Right next to each other.
No. Oh.
Oh, there we go.
I just said, I swear to you.
Yep, you treat the O just like a number. Should have changed color so I can see you guys. Okay, go. You can write at the same time.
Alright. So I need a little bit of help. So, it's on this one. So OH is the phenol, right?
Mm-hmm.
So then do I start there and go ethyl, bromo?
No, it has to start at the phenol.
And then it'll go this way. So bromo, ethyl, chloro.
Right. So
Do I have to number them too?
Mhm.
So like this one, it would.
So the OH is your 1.
So 1.
No, the OH is your 1.
Yes, but I don't need to label that. Okay, so I would do 2 bromo. 3 ethyl.
Nope. Chloro comes next. Alphabet.
Oh yeah. So 2 bromo. 6 chloro. What was it?
Chloro.
CHLORO. Well,
No YL, just chloro.
is it
Bromo.
Bromo, chloro.
Bromo.
Hmm?
BR-MO, not
Oh,
YL.
bromo.
The YL is just for the carbon
So
groups.
2 bromo, 6 chloro, 3 ethyl, phenol.
Don't forget to put your circles in the center. Okay,
And that was a hard one.
you wanted a hard one.
I know. I'm glad I got it. Can they still see that? Yeah.
Yeah. You can watch the notes online. The opportunity is definitely there.
And this is so.
Okay, let's go over these real quick. We are almost out of the period, so we got to hustle. Okay, so on the first one, M-propyl chlorotoluene, is that what I think it says? There's no toluene. Toluene is a 1 carbon attached. This has 2 different things. We have a 2 carbon chain here and we have a 3 carbon chain here. So we just have to name them as we go. So the 3 carbon chain it starts with a P, 2 carbon with an E. So we're going to start here numbering 1, 2, 3.
So why would it be?
Because there's no just straight carbon off, 1 carbon. So we have a 2 carbon chain but not a 1 carbon chain. So this one we're going to name coming through the chlorine first. So 1 chloro, and we just go alphabetically. So 2 ethyl, 3 propyl. Oops, I forgot the dash, and my board is off again, so I'll have to reset it. Benzene. Okay, we're resetting this because I can't stand not being able to know where I'm going. Calibrate it. Okay, so double check, make sure that it's one of the things. On the second one here, yes, we do have an aniline. It's right here. And it's in the ortho position for chlorine, chloroaniline. We're good. On the third one, you have to start counting at, because this is a phenol right here, you have to start counting there at 1. I have to decide if I'm going clockwise or counterclockwise. Counterclockwise will give me the lowest number, so that's the way that you will go. So 2 bromo, 6 chloro, 3 ethyl phenol is correct. Number 4, this is a nitrobenzene by definition. Okay, so you should be able to do that. I'm going to really quickly talk through the others fast. You got off today. All right. because you're pregnant. Fake pregnant, but there. You do need to go back over the substitution reactions. Make sure that you know which one is which. Which one will make a nitro, which one will make a sulfur, and which one will make a chlorine or bromine. Okay? Know that when you have benzene ring, it can only substitute. It cannot break those double bonds. Okay? That's important. Yes, Tiani?
Oh, I'm not raising my hand. Sorry.
Okay. All right. So what I want to go back and have you look at really quickly, if I can find it real fast right here. This class code, we're going to do it next time because we don't have a lot of time here. But you're going to get into ALEKS and do this class code. It will tell me where you're at, and it will help guide my instruction for our review. So I need you to complete it. I don't care if you do it in class. I don't care if you do it out of class, but I'm giving you next period to do it. We also have a screener that you have to take next time, too, in class. So even if you're not 10th grader, the 10th graders will take Aspire, and the rest of us will take a screener. Okay? A science thing, I don't know. District wants it. It doesn't affect your grade, but the district wants it. But this one, I want you to do your best on the ALEKS one. Guys, please listen. Okay, I want you to do your best on the ALEKS one because that will guide my instruction of what you need to know for the final. Because I don't know what you don't know right now. I don't know what you know either. So this, do your very, very best. It will take about 45 minutes to 60 minutes to complete once you start it. Okay? So that's what I'm going to give you next time. And then I've sort of blanked it out. Chapters 1 through 4, chapters 5 through 8. Remember on the 14th, all work is due. So make sure you got it ready to roll before then. And then down to the test with 20% of a grade. Bell should be ringing in about 3 or 4 minutes, so I'm going to stop.
I realize we go until 11:55, right?
Oh, it's 11:55. No, you still have an hour. Thank you. I was like freaking out. I was like, you guys are going to be out of here. Okay, so you have an hour. You can do the ALEKS right now if you want, or you can work on your lab / LearnSmart / whatever. Okay? I'll leave this up there so you can see it. I will enlarge it so you can see the code. Maybe.